Hello everyone, we are presenting our full stack project, a smart AI-based traffic management system. The problem is simple, traditional traffic signals run on fixed timer regardless of actual traffic. This causes unnecessary delays and fuel wastage. Our system solves this by dynamically adjusting signal timing using AI based on real-time traffic data. For the tech stack, our frontend uses HTML, CSS and JavaScript. The backend run on Node.js with Express.js. We use MongoDB with Mongoose for the database, Socket.io for real-time WebSocket communications, and JW2 with bcryptjs for authentications. For security, we use Helmet and Course, and for logging, we use Morgan along with custom file logger built using Node.js stream. Our project follows a clean MVC-style architecture. The public folder has a front-end HTML page and client-server site.js. The server folder contains a backend organized into config, model, middleware, routes, and service. The service folder holds the core logic, our AI engine, traffic simulator, and socket service. And server.js is the entry point that ties everything together.
Hello everyone. Now I will explain the backend of our project. On the screen, you can see our backend starts from server.js, which is the main entry point of our application. Here, we create the Express server using Node.js and configure all middleware. We use middleware like Helmet for security, compression for performance, cookie parser, and Express session for session handling, and Morgan for logging. We also use .env to securely manage environment variables. Next, we have our model files, where we define our MongoDB schemes using Mongoose. We create three main models. User model for authentication with hashed password. Intersection model to store location and signal data. And traffic log model to store real-time traffic information. Then we move to route files, where all API ends are defined. We organize them into API auth, as you can see in the screen, for login and registration using JWT. Intersection for CRUD operations, traffic for traffic data, and signals for signal controls. We also implemented centralized logging for all API requests and added role-based access control so that only admins can perform sensitive operations. Error handling is managed using middleware. So overall, our backend is modular, secure, and easy to explain. Thank you. You may have a nice day.
Now I would like to demonstrate the authentication module of our project, starting with sign-in functionality. Before I begin, let me explain my project. So, our project focuses on building an AI-based smart traffic management system that dynamically control traffic signals based on real-time road condition. The goal is to reduce congestion, minimize waiting time, and make traffic flow more efficient using intelligent decision making. Let me explain the core intelligence of our system. The AI traffic engine, at the heart of this engine is the demand-based scoring mechanism. For each direction, we calculated a score using the formula. Score is equal to vehicle count into 1.0 plus queue length into 1.5. Here, queue length is given higher priority as vehicles that have been waiting longer require more urgent clearance. Based on these scores, the system dynamically distributes a total cycle time of 120 seconds. Each direction is allocated a green signal during ranging between 10 to 60 seconds. To ensure smooth transition and avoid abrupt functionalities, we implement an exponential moving average. This blends 70% of newly calculated timing with 30% of previous value, resulting in stable and realistic signal adjustment. Additionally, the system categorizes traffic condition into four levels: low, moderate, high, and critical, enabling better monitoring and decision making. For simulation, our traffic simulator generates realistic traffic patterns using time of day multipliers 1.8 into during peak hours, 1.0 into during normal day times, and 0.3 during night times. The simulator updates every 3 seconds using set interval and communicates interval via EventEmitter pattern. All process data is transmitted to frontend in real time using socket.io. As demonstrated on the dashboard, vehicle count and signal timing updates instantly without requiring a page refresh. The frontend integrated the fetch API to RESTful communication and socket.ai client for live updates. In conclusion, we have developed a complete full stack solution incorporating core backend and front-end technologies, including the HTTP module, Express middleware, EventEmitter, streams, JW2-based authentication, role-based access control, REST APIs, WebSockets, and AI-driven adaptive traffic control system. Thank you for listening.